Right is a complex number in standard form. Well, we're going to apply Demoivre's theorem, but first I need to write this complex number in trigonometric form. So first I'm going to find the modulus r, which is the square root of 3/2 squared, and then plus 3 square roots of 3 over 2 squared. That equals square root of 9/4 plus, and let's see, 3 squared is 9, and then times another 3, which is 27, over 2 times 2, which is 4. So that 27 is 3 square roots of 3 times 3 square roots of 3. So that's where the 9 comes from, and that's the other 3, to make 9 times 3, which is 27. Okay, so that equals 9 plus 27 is 36. So it's going to be the square root of 36 over 4, which is the square root of 9, which is 3. Okay, all that for a modulus of 3. So r equals 3, and now we need to find the theta. Now tangent of theta equals b over a. In this case we have negative 3 square roots of 3 over 2, then divided by 3/2. So I'm going to flip the second fraction and multiply to get times 2/3 instead. And so that's going to be equal to negative 6 square roots of 3 over 6, which simplifies to the negative square root of 3. Okay, now let's figure out the reference angle and go from there. So the reference angle, if you're doing a tangent and it comes out to be negative square root of 3, well, you're going to be at pi over 3. And then from there it depends on which quadrant you're in. In this case, we are in quadrant number 4 because the a value here is positive and the b value is negative. So that'll put you down here. So this angle going all the way around is 5 pi over 3. Okay, so really that's the hardest part. So our complex number z is equal to 3 times the cosine of 5 pi over 3 plus I times the sine of 5 pi over 3. And that's in trig form. Now we're going to apply Demoivre's theorem, and he says that you can just raise the power. So basically z to the 6th is going to be that whole number to the 6th power. So it's going to be 3 times cosine of 5 pi over 3 plus I sine 5 pi over 3 to the 6th power. Okay, so now I need to distribute out the 6. So this is going to be 3 to the 6th, and then times the cosine of 6 times 5 pi over 3 plus I sine of 6 times 5 pi over 3. Okay, now 6 times 5 is 30, then divided by 3 is 10, so this is the cosine of 10 pi plus I sine of 10 pi. Now reference angle for 10 pi is 0 because that's 5 complete rotations around the circle. So it's going to be the same thing as 3 to the 6th times cosine of 0 plus I sine of 0. The cosine of 0 is 1, sine of 0 is 0. So this is going to be 3 to the 6th times 1 plus 0I, basically. So there's going to be no imaginary part, and it's just going to be 3 to the 6. And 3 to the 6th power is 729. Okay, so there you go. There's your complex number in standard form. Let me review the process. The first part of the process was converting to trigonometric form from standard form. And that was all this work in the left-hand column here, finding theta and also finding the modulus r. And then once we have it in trigonometric form here on the right, we just went ahead and applied Demoivre's theorem, raised it to the 6th power, then simplified all the way down and got 729.